Methane is commonly referred to in its role as an energy source, a key component of natural gas, as well as having an impactful greenhouse effect when released into the atmosphere. However, my discussion today does not center around these mainstream roles of methane, but instead I pose the question, could methane hydrates be dangerous to humans? To begin, methane hydrates only form under specific conditions, and are only found in certain areas of the ocean, primarily the continental margins, and in northern permafrost region. By definition, a methane hydrate is the result of a methane bubble being enclosed by water molecules, requiring low temperature and high pressure conditions. On the left, we see a methane molecule, CH4, and on the right, we see its transition into a methane hydrate molecule. The unexpected and largely unknown outcomes produced by methane hydrates are of interest to me. Additionally, these obscure events, which occur on many scales, inevitably lead to interest by anyone who studies earth sciences. Now we transition into the hypotheses revolving around methane hydrates. First, we will talk about the notorious Bermuda Triangle and how ships often disappear there. Next, we will discuss large, mysterious craters found in Siberia and other northern permafrost regions. As I spoke about earlier, methane hydrates can only form under specific conditions, as shown in the figure on the left. These methane hydrates, which you can see an image of on the right, form over time, and as this occurs, there is an immense buildup of gas pressure within the ice and sediment, and can eventually result in an explosive release. Now, we will talk about how methane hydrates create massive tornadoes over the ocean and result in the release of sea monsters, which can sink ships. You're just kidding. Now, for the actual sinking ship hypothesis. To begin, it is known that the Bermuda Triangle provides sufficient water temperature and pressure to form methane hydrates, which has been proven by scientific research to exist. So here we see in this figure, as methane trapped on the sea floor releases in an explosive fashion, methane bubbles rise to the surface. As these bubbles reach the surface, they compromise the buoyancy of the ship, as they are less dense than both air and the water surrounding the ship, and thus the ship sinks. You may ask, how do we know that methane hydrates could affect the buoyancy of a ship at this scale? On your left, you see an experiment taken on by marine scientists to recreate the conditions of methane hydrate bubbles reaching a 500-foot freighter carrying a 7,000-ton load. In this experiment, the ship ended up sinking due to a loss of buoyancy. On the right, an image shows what a freighter of this size and weight would look like. The second of the sinking ship hypotheses. Compared to methane bubbles affecting the buoyancy of a ship, some scientists propose that as methane bubbles move towards the surface, they condense to form a single large bubble. As this bubble pushes up against the water, it creates troughs on either side, which then could sink an unlucky vessel found in its path. We transition to the second hypothesis, involving Arctic craters, mysterious and found only in permafrost regions. Both of these craters were proposed by scientists to be formed by exploding methane hydrates. Just as we see in the ocean, methane hydrate bubbles can condense together to form an immense amount of pressure. And when this pressure exceeds the sediment and ice binding it, it explodes to form these massive formations. As we wrap up the presentation, we see a map here showing first, in the purple diamond, recovered gas hydrate samples. These areas have been tested by scientists to reveal that there is some amount of gas hydrate buildup. Secondly, we have red dots, which show inferred gas hydrate occurrences. These craters or underwater sediment disruptions have been linked by scientists to explosive release of methane hydrates in particular. As I've shown, scientists have confirmed potentially volatile activity brought forth by methane hydrates, which could in fact be dangerous to humans. And while the observation of this activity in nature has yet to be captured, there are methods which could be used to do so in the future, such as setting up methane observation stations, similar to those used in permafrost regions to measure slow release of methane gas. They could be centered on finding regions where methane hydrates have reached high pressure limits and are about to explode. Additionally, drilling in the ocean could locate more of these high pressure buildups and be observed from afar.